guys, this is going to be that real short video on the periodic table. Make sure you either have one pulled up or one printed out. Okay, so Dmitri Mendeleev was considered the father of the periodic table, and that's because he proposed that when elements are arranged in an order of increasing mass, certain sets of properties are going to recur periodically, which is why it's called the periodic table. So basically what he did, he looked for patterns, and he was able to predict where elements would be. Okay, so here are some patterns. Those colors represent the recurring patterns that happen. So like lithium and sodium have the similar patterns. And you can see this is about right for our periodic table, at least for the first 20. He did arrange them by mass. We now know that they're arranged by atomic number, which we'll talk about later. Okay, I do want you to probably pause and label the metals on a periodic table. So just remember the metals are all on the left side of the periodic table. The nonmetals are on the right. And then there is a staircase here. These are where the metalloids are located. Everything that touches that staircase is considered a metalloid except aluminum. Aluminum is a true metal. It acts like metals. Okay? Don't forget that hydrogen is also non-metal, even though it's on the left side of the periodic table. All right, so let's identify. So A, that barium's a metal. B is a non-metal. Oxygen is also a non-metal. And tellurium is a metalloid. Okay, so just make sure you're labeled. So I've got non-metal, non-metal, metal, metalloid. Okay, those should be super easy points on a test. So please, please, please make sure your periodic table is labeled. As far as metal properties, hopefully you know they're good conductors of heat and electricity. They're malleable, which means they could be flattened into sheets. They're ductile, which means they could be drawn into wires. They're shiny. And the technical term for that is lustrous. Okay. Also, they tend to lose electrons when they go through chemical changes. Nonmetals are basically the exact opposite. Okay. They tend to be poor conductors of heat and electricity. They're going to gain electrons. Instead of being hard and shiny, they're going to be dull and brittle. Okay, things like that. Then our metalloids are going to be right in the middle of both. So they're going to have properties of both. I do want you to know sometimes those metalloids are called semimetals. So just know if you see that name, that's what it's talking about. Okay, so instead of being a conductor, a good conductor, these are semiconductors. Okay, so they can act as either conductors or insulators, but these are really useful in computer chips and cell phones, in our calculators, things like that. And again, these are the ones that touch that zigzag staircase on the periodic table. Then we have our main group elements and our transition elements. So our main group elements are denoted by this A at the top of the periodic table. And then transition elements are in this section, and they have B's on top of them. That bottom section down here that's real long, those are also transition elements. So they're not as predictable. Main group elements are generally predictable based on their position, and those transition elements are less predictable. You will need to know all of the families. There are 4 of them that you need to know along with the transition metals. So family number 1 or group number 1 is called the alkali metals. That does not include hydrogen because hydrogen is not a metal. Group 2 are called the alkaline earth metals. Group 7A, which is the second to last column, those are the halogens. And group 8A are the noble gases. All right, so families. So A, we've got an alkaline earth metal. B, nitrogen is just belonging to group 5A or 15. That group doesn't have a name that we learn. Okay, K, or potassium, is an alkali metal. And bromine is a halogen. Lithium is alkali. Boron is just group 3A. It doesn't have a name that we learn. Iodine is a halogen. And argon is going to be that noble gas. Remember, everybody wants to be like the noble gases. So, here are some pictures of alkali metals. Just some things you need to know. I would go ahead and write down that these have a +1 charge. So if you want to write that above them, that'd be great. Okay, also, they get dull very quickly if you cut them. So they're soft enough to cut because they're metals, but they're soft. And this is lithium. It gets black very quickly. But if we were to like drag a knife across that, it would get shiny and then it would dull very quickly. It would kind of look like it's rusting, but it's not. It's just one of its properties. Sodium is common. If you put it in water, it starts a fire. So these are very reactive elements on the periodic table. And occasionally, fire started in schools are from things like sodium or potassium that people put in water. Okay, we do not have any at Mesquite High. Alkaline earth metals are also very reactive, but they're not quite as reactive. So they will tarnish easily. It's not really tarnishing, but they'll react to the air more easily, so they'll dull, but not quite as quickly. They will burn very, very bright. So magnesium is like you can't even look at it because it'll burn your eyes. Okay, they don't start fires in water, but if we were to put a piece of calcium metal in water, it bubbles a lot and it reacts a lot, just not as violently as starting a fire. But it'll move around in the water and it'll react. Halogens are group 7A. Oh, I did mean to tell you to put a +2 over the alkaline earth metals on your periodic table. As far as the halogens go, I want you to put -1 on top. Okay, they are also very reactive, but these are the nonmetals. Okay, these specific nonmetals will come in all states of matter. So like fluorine and chlorine are going to be gases, bromine's going to be a liquid, and then iodine and astatine are going to be solids. So that's kind of different because most of them are all one state of matter. Noble gases, if you recall, they have no charge if they become ions, and they are unreactive. Sometimes we use the word inert, and that just means they are not reactive. Okay, helium, as y'all know, it's used in balloons. We use balloons today at church. Neon is often in neon signs, but it's not always neon, and we'll talk about that later. And then there's argon, krypton, and xenon. And that's it for periodic table. If you have any